How's it going, guys? Welcome to day 6 of distance learning. We're here again, continuing on with transformations. I'm going to jump right into it again so we can get going through all this and get you the example like we did yesterday when we were talking about translations. So transformations on the coordinate plane, talking about taking the shapes or points and moving them around in some form or fashion on the coordinate plane. Let's go back through again the 3 types. Yesterday we spent time talking about translation. Now, translation refers to the movement of a shape or a point, either up or down, left or right, right? And we call that slide because what happens to the shape, as the example showing up here, is that it slides from one point to the other, meaning the orientation doesn't change. The triangle looks the same here as it did after it transformed over there or translated, okay? So it slid to that position. Today we're going to talk more about the new one here, reflection. Now, when we're talking about reflection, we're talking about actually taking that, and just like you do with a mirror or any kind of reflective surface, is that it's going to reflect across it. Meaning it's not going to be in the same orientation, because what's going to happen is that it reflects across a line of reflection. So our example here, our triangle, the same one, this time when it reflects, it's going to reflect across this line, so the orientation does a flip, right? Think about flip. Like if you're doing a pancake and you flip it, that's the reflection. That's what's happening here, okay? And then tomorrow we're going to get into rotation, where of course we're talking about the actual shape doing a turn around a certain point on the coordinate plane, okay? So, slide, flip, turn. Translate, reflect, rotate. The 3 forms of transformation that can occur on your coordinate plane. Okay, now let's get into reflection, but reminder real quick, when we talk about any kind of transformation that occurs, proper notation requires an apostrophe next to the name of each point. So as triangle ABC does any kind of transformation, it would become transformation triangle A apostrophe B apostrophe C apostrophe for each point, right? Okay, just a reminder on that. Now, let's get into reflection. Reflection rules. There's really 2 primary reflection rules, okay, and they follow as such. If we are reflecting across a y-axis, okay, the y, remember, is the up and down, right? So if we're reflecting across the y-axis, so if we're going from this to this, what's going to happen then is that you have to use the opposite of the x-coordinate, and then we keep the y-coordinate the same, all right? This is one of the reasons why I decided to break this into 3 different days, because each day the rules for transformation are very different, very unique. So an opportunity for it to immerse into your head with the process, the notation, as well as the example of work that you're going to be doing today as well. So this will give you an opportunity to kind of see that these are separate, which means that the processes aren't the same, okay? So again, if we're reflecting across the y, we're reflecting across that y-axis. We're going from this side to this side. Reflection tells us that we are going to take the opposite of the x-coordinate, but we keep the y the same. Remember, again, it's very important to not forget that the ordered pair never changes where you have x, y, right? So the x, we get the opposite of the x, we keep the y. What does that mean? Well, let's get to our example here. Point P. Oh, buddy P is still back again at 3, 2. Well, he's going to reflect across the, or she, I don't know, reflect across the y-axis. And how that works is, as it says in the notes, in the red here, we take the opposite x, keep the y. So if we're reflecting across the y, then the point 3, 2 becomes negative 3, 2. Opposite of the 3, opposite of the x. So if it's 3, it's going to be negative 3. That's what we mean by opposites. We learned this again when we talked about integers last topic. Okay, so that's as simple as it gets. It's really not too difficult, I think, when you're talking about this. It's reflecting by taking the opposite of the x, keeping the y, and we've reflected that point across the y-axis. Okay, now if we're going to reflect across the other way, the x-axis, the horizontal line, well then, if you think about it for a second, we flip what gets changed, meaning we take the opposite of the y-coordinate this time. Okay, so if we're reflecting across that horizontal x-axis, what happens is we take the coordinates, we leave the x the same, but we take the y-coordinate and we flip that right? We take the opposite of the y. So again, let's use point P here. Point P at 3, 2. Moving that across the x. So it's at 3, 2 to start. Well, we take the opposite y, but we keep the x. So that becomes 3, negative 2. Right? 3, negative 2. Negative 2. Okay. Maybe. Sort of. Kind of. Remember, I'm going at a pace that I don't have to worry about you keeping up with the notes. You need to pause as I go if you need to let this sink in, or if you're writing along as you're listening as if you were in class. You can pause me. You wish you can pause me in class. I know you do, or probably actually mute me. But too bad, you can't do that. But at least now you can pause as you move along. Okay? Good. Now, let's see. Let's go with a practice. Of course, we're bringing in a shape. We have a triangle, ABC. ABC is going to get reflected across the axis of Y, right? Then we're going to go ahead and make this extra. I know, make it extra, why not? And go across the X too. So it's going to do 2 reflections. So that means it's going from, based on where it's at, I'm going to say it's a negative positive, so that means it's going to be over in quadrant 2. Good. So we're going to reflect it across the Y, which means it's going to jump across from quadrant 2 over to quadrant 1. Okay? Then we reflect it again from quadrant 1 to quadrant 4, because it's going across the X. You see what happened here? Knowing your quadrants are very important. Kind of let you know where you're going. Okay. So, let's get into it here. So it's as simple as I've said. We're going across the Y first. So if we're going across the Y first, then that tells us we take the opposite x and keep the y. So that becomes a positive 5, 4. But we're moving across the x after that, so that means we got to flip now the y and leave the x alone. So that becomes 5, negative 4. Okay, we actually, I guess, realized I didn't do both flips at once. So here we are, learning as I move. Going across the y, we keep it 5, 4. This one changes, keep the x, keep the y, change the x, 2, 3, negative 3, 1, keep the y, change the x, 3, 1. Then we do the flip across the x-axis. So then 5, 4 becomes 5, negative 4. We change the y, keep the x. 2, 3 becomes 2, negative 3. Keep the x, change the y. Okay. And then 3, 1 becomes 3, negative 1. Okay? Clear as mud, right? Reflection is simple as that. There are 2 rules. If you're going across the y, the coordinates, you change the x, but you keep the y. Reflecting across the x, you keep the x, you change the y to the opposites. Integers again. Opposites, going from positive to negative or negative to positive. Whatever one it's at, you go to the opposite when you're having to change it for that reflection. So, our word example here hopefully helped. If not, let's bring in a little visual assistance. Here's a triangle. Again, ABC, 3 coordinates that we already gave are going to do a reflection, right? So we're going to reflect. We have negative 5, 4. We want that to go across the y right now. So it's going to go across the y. We keep the y, change the x, right? So that becomes positive 5, positive 4. So what happens to point A? It goes from here to there. Okay? You getting this? Maybe? Alright, let's go to the next point. Point B. It's at negative 2, 3. We want that again to jump across the y, so what happens is we keep the y, but change the x, so that becomes 2, positive 3. So that means that moves over to the other side, right? And then the last point, point C, it's at negative 3, positive 1. Reflecting that across the y allows it to become positive 3, positive 1. Okay? So we get our points reflected. We connect the dots. And there we have a reflected shape. Reflected points, reflected shape. This was only the jump across the y. I didn't do the jump across the x, but the same process would still hold true. If we go from here down to here, then 5, 4 would become, right, 5, the x stays the same, but the y becomes the negative 4. Same thing, 2, 3 would become 2, negative 3. And then 3, 1 become 3, negative 1. And then we would have seen the shape reflect again. Okay? Catching this? I hope so. Because, obviously, as it goes, you also have a worksheet involved with this one today. So, let's see if we can jump to the worksheet real quick. Or real slow. Or something. There we go. Alright. So, apologies to the bad pixelation on the zoom in. This is the best I could do to get it to actually show up so that we could actually work one example only. This is example, or problem 1 on the actual worksheet that is going to be posted with this video on the Google Classroom. So let's talk about it. How are we going to handle this? We have this time 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. What can I say? I'm giving you guys some challenge, right? Yes, challenge. So, we want to reflect this across the x-axis. Remember, your x is the horizontal. So you want this shape to reflect across the x. What's going to happen then is that it's going to flip across the x-axis, right? Alright, let's see if the board's going to be nice to us today. Starting off, we have our first point here at 1, 1. If we're wanting to reflect that across the y, the x, I already messed up. Across the x, what happens? Well, we keep the, are we catching this here? Keep the x, change the y. So that becomes 1, 1 becomes 1, negative 1. See if that catches up with us. Alright, we have our next point right next to it here, which is at 2, 1. 2, 1 reflects across the x, so it becomes 2, negative 1. Okay? Alright, moving along. We have our next point. We're going to go up here. We have 0, 2. So our reflection would be 0, negative 2. Alright, moving right over next to it. 1, 2 becomes 1, negative 2. Good? Catching on here? 2, 2, 2, negative 2. 3, 2, 3, negative 2. Why are you spinning on it? Okay. Work with me, not against me, computer. Alright, and we're going to leave it there. Okay, moving on. Next up, we have 1, 3. Well, that becomes 1, negative 3. And then we have 3, 3. So that would become 3, negative 3. And then we have 2 more left. 0, 4. Well, that should be, give me a point. We're going to be a little bit of a cheater here and move it that way. Okay. That becomes 0, negative 4. And then our last point, that is at 1, 4. That becomes 1, negative 4. Okay. Looks like a jumble of dots right now, right? But if we again connect our dots, if the computer is nice and lets us do this, which it's not working with me. Okay, so we have that point that connects. We have that point that connects. We have this point that connects. Nope. Keep moving along here. Another one that connects. Another one that connects, hopefully. This is not ideal, but it's going to work hopefully for us. Oh, that actually goes right there. Okay. And we have the shorter. That goes there. That one jumps here. We have another one. We have another one going there. This is a jumble today. Oh, my My new word of the day, jumble. If it doesn't work the way you want it, you make it work. So, not as pretty, but it's still reflective. Again, follow the rules. Reflecting across the X, we keep the X, we change the Y. Reflecting across the Y, we keep the Y, we change the X to the opposite. Simple as that. There's 5 more of these for you to work on your own. Cami, you can do the same exact thing. Drop the dots, draw the lines, recreate the shape. Hopefully a lot easier than the board just worked with me today. I hope. Anyways, that wraps it up for today. We'll be back tomorrow when we talk about rotation. Make sure you're taking care of business. Reach out to me if you have concerns. Today I have Google Meets with first and third hour. First is at 10 a.m., third hour will be at 11. The links will pop up on our Google Classrooms. We'll see you then.